Good morning, students. Am I audible clearly?
Yes, ma'am.
Yes. Okay, we will start with the class. Yes. So our today's topic is wave optics. Okay. So last class alli now ray optics anna discuss madidvi. Ray optics alli now what do you mean by the ray? What do you mean by the optics? Anta kuda discuss madidvi. Then related to that some concepts also we have discussed. Yes. So now today we are going to start with the next topic, that is, so based on wave optics, it is having 3 to 4 marks weightage in your CET exam. Aita? So let us see first some of the concepts in this wave optics. Aita? So already wave antandre niಮಗೆ ಗೊತ್ತಿದೆ. What do you mean by wave here? Okay, what do you mean by wave here? Wave is nothing but what? Wave is nothing but it is the disturbance created in the medium. Whenever the disturbance is created in the medium, here the waves are generated. For example, if you consider the water, ನೀವೀಗ ಒಂದು ಲೇಕ್ ಅಲ್ಲಿ ಅಥವಾ ಎಲ್ಲಾದ್ರೂ ರಿವರ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ವಾಟರ್ ವಿಲ್ ಬಿ ಅಟ್ ರೆಸ್ಟ್. ನೀವೇನಾದ್ರೂ ಅದರಲ್ಲಿ ಒಂದು ಸ್ಟೋನ್ ಹಾಕಿದ್ರಿ ಅಂತಂದ್ರೆ, ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ವೆನ್ ಯು ಥ್ರೋ ಎ ಸ್ಟೋನ್ ಇನ್ ಟು ದಟ್, ದ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ಸರ್ಕಲ್ಸ್ ಆರ್ ಫಾರ್ಮ್ಡ್ ಇನ್ ದ ವಾಟರ್. ಕಾನ್ಸೆಂಟ್ರಿಕ್ ಸರ್ಕಲ್ಸ್ ಫಾರ್ಮ್ ಆಗತ್ತಲ್ಲಿ, ಹೌದಾ? ಸೊ ದಟ್ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ಸರ್ಕಲ್ಸ್ ವಾಟ್ ಎವರ್ ಇಟ್ ಇಸ್ ಫಾರ್ಮಿಂಗ್, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದಿ wave here. That is called as wave. Okay, what is wave optics? Wave optics is nothing but here optics is the branch of physics which deals with the light and the light phenomena. Then ಏನೇನ್ ಇರತ್ತಪ್ಪ ಈ ಟಾಪಿಕ್ ಅಲ್ಲಿ ನಾವ್ ಏನೇನ್ ನೋಡ್ತೀವಿ, ಇದ್ರಲ್ಲಿ ನಾವು ಸ್ಪೆಷಲ್ 3 ಫಿನಾಮಿನಾಸ್ ವಿ ವಿಲ್ ಸ್ಟಡಿ ಫಾರ್ ದ ಲೈಟ್. ಸೊ ಇಷ್ಟು ಕ್ಲಾಸ್ 11th ವರೆಗೆ ಅಥವಾ ಕ್ಲಾಸ್ 10th ವರೆಗೆ ನೀವು ರಿಫ್ಲೆಕ್ಷನ್, ರಿಫ್ರಾಕ್ಷನ್ ಕಲ್ತಿದ್ದೀರಾ, ಡಿಸ್ಪರ್ಷನ್ ಆಫ್ ಲೈಟ್ ಕಲ್ತಿದ್ದೀರಾ. Today in this wave optics ನಾವೇನ್ ನೋಡ್ತಾ ಇದೀವಿ ಅಂತಂದ್ರೆ, we are going to discuss about the interference of light, the diffraction of light and the polarization of light. So one by one what is the definition ಮತ್ತೆ ಅದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ಏನಾದ್ರೂ ಫಾರ್ಮುಲಾಸ್ ಇದ್ರೆ ನಾವು ಅದನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಓಕೆ, so before going to study the interference of light ಅನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ, ಇದು wave optics it will start from one theory that is called as Huygens principle ಅಂತ ಹೇಳ್ತಾರೆ. So Huygens principle ಅನ್ನ ಡಿಫೈನ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ one basic definition we require here, because Huygens will explain his principle based on the corpuscular theory. So what is corpuscles? Let us see that one. Okay, so what do you mean by corpuscles here? That is light is made up of what? Small discrete particles. Light is made up of small discrete particles. Whatever these discrete particles are there, these are called as what? Corpuscles. These are called as the corpuscles. Okay, so this corpuscles theory was given by Newton. First actually Newton ಕೂಡ ಇದನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾರೆ. ಅದರ ನಂತರ the theory was developed by Huygens here. So Huygens will develop the Newton concept. Newton concept ಅನ್ನೇ Huygens develop ಮಾಡ್ತಾರೆ in the year of 1678. 1678 ಅಲ್ಲಿ the Newton ಏನ್ ಬೇಸಿಕ್ ಕೊಟ್ರು for the wave optics, ಅದನ್ನ that is Dutch physicist Christian Huygens will develop that theory. ಆಯ್ತಾ? Then next in the 1801 Thomas Young will come. ಈ ತರ ಮತ್ತೆ ಬೇರೆ ಬೇರೆ ಸೈಂಟಿಸ್ಟ್ ಏನ್ ಮಾಡ್ತಾರೆ, ವಾಟ್ ಎವರ್ ದ ಥಿಯರಿ ವಾಸ್ ದೇರ್, ಇಟ್ ವಾಸ್ ಡೆವಲಪ್ಡ್ ಸ್ಲೋಲಿ. ಸೊ ಫಸ್ಟ್ Huygens principle ನೋಡೋಣ ನಾವು. So what is this Huygens principle states? The Huygens principle states that here the Huygens principle states that the wavelets is the basis for the wave theory. So illen wave theory anna ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. Huygens ಏನಂತ ಹೇಳ್ತಾನೆ, Huygens will say that the base for this wave theory is wavelets. It is nothing but wavelets here. So what do you mean by wavelets? We will see that. So it is useful for finding the position and construction of the new wave front. So ಇಲ್ಲಿ ನಾವು ಏನ್ ಹೇಳಿದ್ವಿ, suppose if you throw the stone in the water, ನೀವೇನಾದ್ರೂ ವಾಟರ್ ಅಲ್ಲಿ ಸ್ಟೋನ್ ಡ್ರಾಪ್ ಮಾಡಿದ್ವಿ ಅಥವಾ ಬಾಲ್ ಏನೇ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನ ಹಾಕಿದಾಗ ಏನಾಗುತ್ತೆ, ಹಿಯರ್ ದ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ಸರ್ಕಲ್ಸ್ ಆರ್ ಫಾರ್ಮ್ಡ್. ಹೌದಾ? ಸೊ ಹಿಯರ್ ವಾಟ್ ಎವರ್ ದೀಸ್ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ಸರ್ಕಲ್ಸ್ ಆರ್ ಫಾರ್ಮ್ಡ್ ಅಟ್ ಎನಿ ಮೂವ್ಮೆಂಟ್, that was given by Huygens principle. So here wavelet and the wavefront anta ಎರಡು words anna use ಮಾಡ್ತಾನೆ ಇಲ್ಲಿ. So here we need to understand that every point in the given primary wavefront. So ನಾನು ಪದೇ ಪದೇ ಇಲ್ಲಿ wavefront ಅಂತ ಹೇಳ್ತಿದ್ದೀನಿ. ಹೌದಾ? So wavefront ಅಂದ್ರೆ first ನಾವು ನೋಡೋಣ. So what is wavefront here? It is nothing but a source of light. It is nothing but a source of light sends disturbance in all the directions, sends disturbance in all the directions. So this is nothing but the source of light which sends the disturbance in all the directions here. That is called as what? Wavefront here. So it is nothing but it is continuously it is sending the energy or the disturbance in all the directions here. So the wavefront ಅಂದ್ರೆ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಏನ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇದೆ, ಇಲ್ಲಿ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ರಿಂಗ್ಸ್ ಫಾರ್ಮ್ಸ್ ಆಗ್ತಾ ಇದೆ ಅಥವಾ ಈ ತರ ಏನಾದ್ರೂ ಫಾರ್ಮ್ಸ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಇದನ್ನ ನಾವು ಸಿಂಪಲ್ ವರ್ಡ್ಸ್ ಅಲ್ಲಿ ವೇವ್ ಫ್ರಂಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. ಆಯ್ತಾ? ಸೊ ಹಿಯರ್ ದ ಶೇಪ್ ಆಫ್ ದ ವೇವ್ ಫ್ರಂಟ್ ಇಟ್ ಇಸ್ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ಸೋರ್ಸ್. ಹಿಯರ್ ನೀವು ಯಾವ ತರ ಸೋರ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀರಿ ಅದ್ರ ಮೇಲೆ ನಿಮ್ದು ವೇವ್ ಫ್ರಂಟ್ ಡಿಸೈಡ್ ಆಗತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಯು ಹ್ಯಾವ್ ದ ಸ್ಪೆರಿಕಲ್ ವೇವ್ ಫ್ರಂಟ್, ಇಫ್ ಯು ಹ್ಯಾವ್ ದಿ spherical wavefront, so for the spherical wavefront a point source andre namdu source enide, a point source of light we are using. When we use the point source of light, we are getting the spherical wavefront. Then the second type of wavefront is cylindrical wavefront. So what is cylindrical wavefront? When we can get it, that is if a source of light is, it is linear in shape. If the source of light is linear ಅಂತಂದ್ರೆ ಈ ತರ ಏನಾದ್ರು ಸ್ಟ್ರಕ್ಚರ್ ಇದ್ರೆ, ನಮ್ ಇದರಿಂದ ಏನಾದ್ರು ಲೈಟ್ ಬರ್ತಾ ಇದ್ರೆ ಅವಾಗ ನಾವ್ ಇದನ್ನ ಏನಂತ ಹೇಳ್ತೀವಿ? ದಟ್ ಇಸ್ ಇಟ್ ಇಸ್ ಗಿವಿಂಗ್ ಯು ದ ಸಿಲಿಂಡ್ರಿಕಲ್ ವೇವ್ ಫ್ರಂಟ್. ದೆನ್ ಸ್ಪೆರಿಕಲ್ ಯಾವಾಗ ಬರುತ್ತೆ? ಪಾಯಿಂಟ್ ಸೈಜ್ಡ್ ಸೋರ್ಸ್ ಇದ್ದಾಗ ಸ್ಪೆರಿಕಲ್ ವೇವ್ ಫ್ರಂಟ್ ಬರುತ್ತೆ. ಸಿಲಿಂಡ್ರಿಕಲ್ ವೇವ್ ಫ್ರಂಟ್ ಯಾವಾಗ ಬರುತ್ತೆ? ದ ಲೀನಿಯರ್ ಶೇಪ್ಡ್ ಪಾಯಿಂಟ್ ಸೋರ್ಸ್ ಇದ್ದಾಗ ಬರುತ್ತೆ. Then the last third type of wavefront is the plane wavefront. So when we will get the plane wavefront here, a small portion of a spherical or a cylindrical wavefront at large distances. ನೀವು ಯಾವಾಗ ಇದೇನ್ ಸೋರ್ಸ್ ಇದೆ ಲೀನಿಯರ್ ಅಥವಾ ಪಾಯಿಂಟ್ ಸೋರ್ಸ್ ಅನ್ನ ಇಫ್ ಯು ಅಬ್ಸರ್ವ್ ಇಟ್ ಫ್ರಮ್ ದ ಲಾರ್ಜ್ ಡಿಸ್ಟೆನ್ಸಸ್, ನೀವೇನಾದ್ರೂ ಬಹಳ ದೂರದಿಂದ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಇದ್ರೆ, ದಟ್ ಟೈಮ್ ಹಿಯರ್ ವಾಟ್ ಎವರ್ ದ ವೇವ್ ಫ್ರಂಟ್ಸ್ ಆರ್ ಕ್ರಿಯೇಟೆಡ್, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದಿ ಪ್ಲೇನ್ ವೇವ್ ಫ್ರಂಟ್ಸ್ ಹಿಯರ್. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಪ್ಲೇನ್ ವೇವ್ ಫ್ರಂಟ್. So spherical ಮತ್ತೆ cylindrical ಏನ್ ವೇವ್ ಫ್ರಂಟ್ ಇದೆ, when you observe it from the far distance, it will look like a plane wave front. These are the three types of the wave front here. Wave front is nothing but it is a source of light sending the disturbance in all the directions. Okay. Then Huygens principle, already I told you here. Huygens principle, what it states here, that is every point on the given primary wave front, it acts as a source of secondary wave front. ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ನೀವು ಸ್ಟೋನ್ ಅನ್ನ ಡ್ರಾಪ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಫಸ್ಟ್ ಸರ್ಕಲ್ ಫಾರ್ಮ್ ಆಯ್ತು. ಸೊ ದಿಸ್ ಫಸ್ಟ್ ಸರ್ಕಲ್ is acts like object, ಅದು ಅದನ್ನ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ ಸೆಕೆಂಡ್ ಸರ್ಕಲ್. then second circle will form like a object or the source here, then it will create the third, fourth. ಈ ತರ ಏನಾಗುತ್ತೆ, each wave front is behaving like a own source of light here. That is called as what? Or the own source of the creation. That is called as the Huygens principle here. So we have discussed Huygens principle, then the wavefront, then the types of wavefront here. Okay, so some of the properties of the Huygens principle we need to understand. So what are the properties are there? Here each point on a wavefront acts as a source. So the first point is what? Each wavefront, it acts like a source here. Then the second one is the secondary wavelets is spread out in all the directions. So whatever the secondary wavelets are there, it spreads in all the directions anta ಹೇಳ್ತಾರೆ. Then the third one is, that is a new wavefront at any later time is given by the forward envelope. ಅಂತಂದ್ರೆ here whatever the new wavefront is forming here, that is given by the forward wavefront. ಅಂದ್ರೆ ಈ ತರನೇ ಕಂಟಿನ್ಯೂ ಆಗುತ್ತೆ, it will not come back in the direction. Okay, that is the Huygens principle properties anta navilli helbodu. Then after this we can go for the coherent and the incoherent or the interference phenomena. So the first phenomena in this lesson is interference. So what do you mean by interference here? interference is nothing but that is the superposition of the waves anta ಹೇಳ್ತಾರೆ. So here if the waves are superimposing on each other, then the resultant whatever you are getting means here one wave is there and the other wave is there. So when they will superimpose on each other, when they will superimpose on each other, here whatever the resultant displacement of the particle you are getting, this is called as what? Interference phenomena. This is interference phenomena. Here to occur the interference, what is required here? We require two source of light with which must be coherent, which must be coherent anta ಹೇಳ್ತಾರೆ. We require two source of light which must be coherent. And when you can say that they are coherent here, that is if the phase difference between these two waves does not change with time ಅಂತಂದ್ರೆ phase difference constant ಇರಬೇಕಾಗುತ್ತೆ. So interference ಯಾವಾಗ ಬರುತ್ತೆ? When you have the two source of light which should be of coherent. Then when you can say that it is a coherent, when the phase difference must be constant here. Here by chance if you are changing this phase difference, here what happens? The position of the maxima and the minima in the interference pattern, it is changing, or we cannot obtain it in the particular manner here. We cannot obtain in a particular manner. Okay. So that is what? That is interference of light. And here the condition for interference of light. Here we require some values, that is the path difference between the two phases for constructive interference. So here these values you remember, and then namge athara enadru questions bandre directly ನಾವು ಅಲ್ಲಿ note down ಮಾಡಬಹುದು. So for the constructive interference, the path difference value is, so path difference value ಏನಿರುತ್ತೆ? That is nothing but n lambda here. For destructive interference, the path differences, it is n plus 1 by 2 into lambda. ಇಲ್ಲಿ ನೋಡಿ ಇದು ಏನು ಡಿಸ್ಟ್ರಕ್ಟಿವ್ ಇಂಟರ್ಫರೆನ್ಸ್ ಇಕ್ವೇಶನ್ ಇದೆ, ಇದನ್ನ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಅವರು ಈ ತರ ಕೂಡ ಕೊಡಬಹುದು. That is n lambda plus lambda by 2. So don't get confused here. That is n plus 1 by lambda into lambda is same, or this is also same here. This is what the path difference value for constructive and destructive interference. Okay, then here we have the resultant amplitude. So the resultant amplitude for the interference waves is given by, it is y is equal to a cos of omega t. It is omega t plus phi. A cos omega t plus phi by 2. So this is what? This is the displacement, resultant displacement formula idu. Aita. Then the resultant intensity formula. So let us see the resultant intensity formula. It is given by I is equal to 4 I naught. I is equal to 4 I naught cos square pi by 2. So that is I is equal to 4 I naught cos square pi by 2. This is the resultant intensity formula. So for constructive interference, the value is 0, plus or minus 2 pi, plus or minus 4 pi, and so on. It is even multiple. Then for destructive interference, the pi value is, it is plus or minus pi and plus or minus 3 pi, plus or minus 5 pi. It is odd multiple. Here it is odd multiple. Okay. Here, if you consider the A1 and the A2 are the amplitudes, if you consider A1 and A2 are the amplitude, then the resultant of the wave is given by under root of, it is A1 square plus A2 square plus 2A1 A2 cos of phi. So this is the resultant in terms of amplitude. Okay. So similarly, we can write the resultant intensities here. The resultant intensity is given by, it is I1 square plus I2 square plus 2I1 into I2 into cos of phi. So I am giving you all the resultant formulas how to calculate. Okay. So next one more formula here, the ratio of the maximum and the minimum intensity. So the I max is maximum intensity, I minimum is the minimum intensity. It is given by A1 plus A2 divided by A1 minus A2 whole square. So if I substitute the value in terms of intensity, the value becomes I1 plus under root of I2 divided by under root of I1 minus under root of I2. So ನೀವೇನಾದ್ರೂ ಬುಕ್ ಒಟ್ಟಿಗೆ ಕೂತ್ಕೊಂಡಿದ್ರೆ ನೀವು ಈ ಫಾರ್ಮುಲಾಸ್ ಅನ್ನ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಬಿಕಾಸ್ we have the numericals on these formulas. ಆಯ್ತಾ? Next, here we have the relation between intensity and the wavelength and the width of the slit, and that is given by, it is I1 by I2 is equal to A1 square by A2 square. A1 A2 ಅಂತಂದ್ರೆ amplitude ಆಗುತ್ತೆ. So the width, slit width do omega 1 by omega 2. So this is the additional formula. You remember this. Okay. So this is regarding the interference of light. Here, then next we have the Young's double slit experiment. So double slit experiment and ನಾನು ಇಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಕ್ ಹೋಗಲ್ಲ ಆಯ್ತಾ. So Young's double slit ಅಲ್ಲಿ ನಾವು ಅಲ್ಲಿ ಏನ್ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ, that is the fringe width we define there. So the fringe width formula I'll tell you. The fringe width is given by beta is equal to lambda into d divided by small d here. So what is capital D? Capital D is the distance between the slit and the source. It is the distance between the screen and the source anta helbodu. Small d is the distance between the separation, distance between the sources here, distance between the sources, that is given by small d. Okay. So this is regarding the fringe width formula. Then next, we have the interference formula, interference phenomena due to reflected wave, due to reflected wave. So due to reflected wave, the constructive interference, the formula is given by 2 mu t cos of r, which is equal to 2n plus 1 into lambda by 2, where n is 0, 1, 2, 3, 4 value. Okay, this is for the constructive interference. Similarly, for the destructive interference, it is 2 mu t cos of r is equal to n into lambda. This is interference for the reflected wave. Then interference due to the transmitted wave. For constructive interference, it is given by 2 mu t cos r is equal to n lambda. Matte for destructive interference, it is 2 mu t cos r is equal to 2n plus 1 into lambda divided by 2. Okay, so these are the formulas for the interference by the reflected wave and for the transmitted wave. So the last 2 points, that is diffraction and the polarization. Yes. So what is diffraction of phenomena here? The phenomena of diffraction, it is nothing but what? It is the light is bending, right? So light it is bending when it is crossing through the edges here. So the bending of light, depending on the relative size of the aperture and the wavelength, that phenomena is called as what? Diffraction of light. So diffraction you detail alli kaltidira already theory part alli. Hauda? So in case of a diffraction of the light, the minimum diffraction pattern formula, it is given by, that is the minimum diffraction pattern consists of, it is A sin theta is equal to n lambda or m lambda also you can take, where m is taking the value plus 1 plus 2 plus 3 like that. This is what the minimum. Then for the maximum condition, it is A sin theta is equal to, it is A sin theta is equal to m plus 1 divided by 2. M plus 1 divided by 2 into lambda. M plus 1 divided by 2 into lambda. Okay. So this is the diffraction minimum and maximum condition. Here the angular width for the central maximum is given by, angular width for the central maximum is theta is equal to 2 lambda upon A. Okay, then the intensity formula is for the diffraction phenomena, the intensity pattern I theta is equal to Im into bracket sine of alpha divided by alpha whole square, where your alpha is nothing but pi a upon lambda into sine theta, pi a lambda into sine theta. Okay, so this is regarding the diffraction of light. Then we have the resolving power of the optical instrument. The resolving power of the optical instrument is given by, it is 1 upon limit of resolution. Then the resolving power of the microscope is given by, I'm just giving you the main formulas. Full lesson explain ಮಾಡುವ ಅಷ್ಟೇನ್ ಟೈಮ್ ಸಿಗಲ್ಲ ಇದರಲ್ಲಿ. ಸೊ ನಾನು ನಿಮಗೆ ಮೇನ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಮತ್ತೆ ಫಾರ್ಮುಲಾಸ್ ಅನ್ನ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ನಮ್ದು ಏನ್ ಕ್ವಶನ್ ಆನ್ಸರ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ ಅಲ್ಲಿ ನಾವು ಮತ್ತೆ ನೋಡ್ತಾ ಹೋಗೋಣ. That is resolving power of the microscope. The formula is D is equal to lambda divided by 2 mu sin theta. This is the resolving power for the microscope. Then for the telescope, the resolving power of the telescope is given by d theta is equal to 1.222 into lambda divided by capital D. So capital D is the diameter here, diameter of the telescope objective. Okay, so this is what regarding the resolving power of microscope and the telescope. Then the last phenomena in the lesson is, that is polarization. So what do you mean by polarization here? Polarization is nothing but it is the phenomena of restricting the oscillations of a wave just in one dimension. So the one direction is called as what? Polarization. So here now in ಮಾಡ್ತೀವಿ, that is we will restrict the oscillations in one particular direction, that is called as the polarization here. Okay, so this is the theory regarding the wave optics. Now let us go for the question answers. So first we will discuss some of the questions, then we will see the previous year questions. So previous years last 10 minutes I'll solve the questions. Now we will go for the first question. By corpuscular theory of light, the phenomena which can be explained is refraction, interference, diffraction, polarization. Yes, correct. So Kumar, other students, Shilpa is right, Praveen is right, Damini, yes, Parvati, Harshita, yes. That is option A is correct here. That is by using the corpuscular theory we can explain the refraction of light. Option A is correct. Then our next question. According to corpuscular theory of light, the different colors of light are due to different electromagnetic waves, different force of attraction among the corpuscles, different size of the corpuscles, none of the above. Yes. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ the light is giving you different colors. So according to corpuscular theory ಯಾವ್ದು ಇದರಲ್ಲಿ ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ ಅವರು. Yes. So everybody is confused in this question, I think so. ಯಾಕಂದ್ರೆ ಎಲ್ಲರೂ ಬಿ ಸಿ ಡಿ ಬೇರೆ ಬೇರೆ ಆಪ್ಷನ್ ಹೇಳ್ತಿದ್ರೆ ನೋಡಿ ಇಲ್ಲಿ ಅಕಾರ್ಡಿಂಗ್ ಟು ಕಾರ್ಪಸ್ಕಲರ್ ಥಿಯರಿ ದ ಲೈಟ್ ಈಸ್ ಗಿವಿಂಗ್ ಯು ದ ಡಿಫರೆಂಟ್ ಕಲರ್ಸ್ ಎದ್ರ ಪ್ರಕಾರ ಅಂತಂದ್ರೆ ಬಿಕಾಸ್ ಆಫ್ ದಿ ಡಿಫರೆಂಟ್ ಸೈಜ್ ಆಫ್ ದ ಕಾರ್ಪಸ್ಕಲ್ಸ್, ಡಿಫರೆಂಟ್ ಸೈಜ್ ಆಫ್ ದ ಕಾರ್ಪಸ್ಕಲ್ಸ್. ಓಕೆ, so different force of attraction among the corpuscles baralla, different electromagnetic waves. No, option C is the correct option. Next question. Huygens conception of secondary waves allows us to find the focal length of a thick lens is a geometrical method to find a wavefront, is used to determine the velocity of light, is used to explain polarization, is used to explain polarization. Yes. Abhishek is saying B. Shilpa is also saying B. Kumar, Soundarya is telling C. Akash, Praveen, yes. So you all are correct. That is option B is correct. Aita. It is a geometrical method to find the wavefront. It is the geometrical method to find the wavefront. That is correct option. Option B is right here. Next. So here is your next question. The idea of the quantum nature of light has emerged in an attempt to explain interference, diffraction, radiation spectrum of a black body, polarization. The quantum nature of light has emerged to attempt to explain. So interference, diffraction ಮತ್ತೆ polarization ಅನ್ನು ನಾವು ಈಗಷ್ಟೇ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. Yes, correct option. So these all are explained with the help of what? That is wave nature. These are explained with the help of wave nature. The radiation spectrum of a black body is explained with the help of what? Quantum nature. Okay, it is explained with the help of quantum nature. So option C is correct. Other phenomena are explained based on the wave nature. Only the radiation spectrum of a black body is with the help of a quantum nature. Then the next question. Two coherent sources of light can be obtained by two different lamps but the same power, two different lamps of same power and having the same color, none of the above. The coherent source of light can be obtained by correct Shilpa, Harshita. So coherent source of light ಬೇಕಂತ ಅಂದ್ರೆ ನಮಗಲ್ಲಿ same wavelength ಎಲ್ಲ ಬೇಕಾಗುತ್ತೆ. So here none of the above it is. Okay, none of the above. Option D correct ಆಗಿದೆ ಆಯ್ತಾ. Then the next question. By Huygens wave theory of light we cannot explain the phenomena of. So by Huygens wave theory of light ಯಾವ ಫಿನಾಮಿನಾನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಇಂಟರ್ಫರೆನ್ಸ್, ಡೈಫ್ರಾಕ್ಷನ್, ಫೋಟೋಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್, polarization. C. Okay. Yes. Right. Correct everyone. Right. So everybody knows here that is the photoelectric effect. Then the next question. The phenomena of interference is shown by longitudinal mechanical waves only, transverse mechanical waves only, electromagnetic waves only, all the above types of waves. Yes. The phenomena of interference is shown by Kumar, Parvati, Damini. Yes, correct everyone. Yes. So ಇಲ್ಲಿ longitudinal waves ಇರ್ಲಿ ಅಥವಾ transverse waves ಇರ್ಲಿ ಅಥವಾ electromagnetic waves ಇರ್ಲಿ ನಾವು ಎಲ್ಲದರಲ್ಲಿನೂ interference of light here we can explain. Option D is 100% right ಆಯ್ತಾ. Very good. Okay. Next question ನೋಡಿ. Two coherent monochromatic light beams of intensities I and 4I are superimposed. So ಇಲ್ಲಿ ಏನಂತ ಹೇಳ್ತಿದ್ದಾರೆ, you have the monochromatic light beams of intensity I and 4I superimposed ಆಗ್ತಾ ಇದೆ. ಅಂದ್ರೆ they are what you can say, the interference phenomena is taking place. The maximum and the minimum possible intensities in the resulting beam are. So ನಾನು ನಿಮಗೆ theory explain ಮಾಡಬೇಕಾದ್ರೆ intensities ದು formula ಹೇಳ್ಕೊಟ್ಟೆ ಹೌದಾ. So let us see how to solve this. That is the maximum ಮತ್ತೆ minimum ಎರಡು ಕೇಳಿದ್ದಾರೆ ಅವರು ಇಲ್ಲಿ. The maximum intensity is given by, it is under root of I1 plus under root of I2 whole square. Yes. So I1 ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ ಅವರು, I ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. Then I2 value is how much? It is 4I whole under root. Okay. Then it is whole square. Yes. So if I simplify this, here I am going to get it as 9I. Similarly, the minimum condition ella en barutte heli, the formula is nothing but what? The intensity minima is equal to, it is under root I1 minus under root I2 whole square. So again, substitute the value of I1 and I2, we will get it as I. Yes. So option, which one? Yes, correct. Okay. C is right here. I hope the solution is clear to everyone. Howda? So E concept mele there is a possibility one question antu bande barbodu. So idu intensity maximum minimum mele sariyagi nodkolli aita. Next question. Light appears to travel in a straight line since it is not absorbed by the atmosphere, it is reflected by the atmosphere, its wavelength is very small, or its velocity is very large. Yes. Now ಹೇಳ್ತೀವಿ, the property of the light we describe like the light travels in a straight line ಅಂತ ಹೇಳ್ತಾರೆ. ಹೌದಾ? ಎದಕ್ಕಪ್ಪ, ಯಾವ್ದಕ್ಕೋಸ್ಕರ? Yes, ಹರ್ಷಿತಾ, ಅಭಿಷೇಕ್, Kumar. Yes, everyone right here. So the right option is option C. Option C is right here. That is, its wavelength is very small. Its wavelength is very small. Because of that reason, light travels in a straight line. Then the next question. The idea of secondary wavelets for the propagation of waves was first given by Newton, Huygens, Maxwell, Fresnel. Yes. Sariyagide. That is option B. Lohit, Hema, Harshita. Yes, everyone right here. The option B, Huygens is the correct option. Huygens is the right option. Then the next question. By a monochromatic wave, we mean. So what is the meaning of monochromatic wave? A single ray of a single color, a wave having a single wavelength, many rays of single color. Yes. It is B or C. So Lohit, Shilpa, correct. Wave having a single wavelength. Option C is correct here. Option C is correct. Single color baralla. That is what the wave having a single wavelength. By monochromatic wave, we mean that the waves are having a single wavelength. Option C is right. Then the next question. The similarity between the sound waves and the light wave is the similarity between the sound wave and the light wave. Yes. Both are electromagnetic waves. Both are longitudinal waves. Both have the same speed in a medium. They can produce interference. See baratte. Both have the same speed in the medium. No, that is not at all possible. Their longitudinal waves adu kuda baralla, because one is a longitudinal wave and the other one is a transverse wave illi. Hauda? Both are electromagnetic wave. Light is an electromagnetic wave, and the sound electromagnetic wave alla adu. Hauda? So therefore we are left with only one option. Yav bantalli? Tarun, Parvati. Yes, it is option D. Enadu, that is, they can produce the interference pattern. So here the sound and the light both will produce the interference pattern. Then our next question. The ratio of intensities of two waves is 9:1. they are producing interference. The intensity ratio kottidare 9:1 anta. The ratio of maximum and minimum intensities will be. Yes. So ನಾನು ನಿಮಗೆ theory question ಹೇಳಬೇಕಾದ್ರೆ maximum ಮತ್ತೆ minimum ಅದ್ದು formula ಹೇಳಿದ್ದೆ ಆಯ್ತಾ. So let us see that is given by I max upon I minimum. Just now you have taken no I max and I minimum formula. So take that I max and I minimum formula, then simplify that. Okay. Yes, option C is right. So here is the solution. Then the next question. So here is our next question. A wave can transmit dash from one place to another. Yes, very simple and the direct question it is. That is, it will transmit ratio of their amplitudes will be. Yes. What is the answer? Okay, now you check. I hope it is audible now. Yes, okay, okay. Yes, option A is right. That is, their phase differences remain constant. So, idannu kuda ನಾವು theory discuss ಮಾಡಿದ್ವಿ. Then the next question, wave nature of light follows because light rays travel in a straight line. Light exhibits the phenomena of reflection and refraction. Light exhibits the phenomena of interference. Light causes the phenomena of photoelectric effect. Wave nature of light ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಇಲ್ಲಿ. Yes, it is option. Yes. C. Yes, Parvati, you are right. Yes, correct, everyone. So option C is correct here. That is, light exhibits the phenomena of interference. Light exhibits the phenomena of interference. Yes. Then our next question. Colors of thin films result from, or on a rainy day, a small oil film on water shows brilliant colors. This is because of dispersion of light, interference of light, absorption of light, scattering of light. So the color of the thin film is due to option D. B. Shilpa Damini is saying option B. Correct. So ಇಲ್ಲಿ ನಾವು ಏನ್ ಕಲರ್ಸ್ ಅನ್ನ ನೋಡ್ತೀವಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸ್ಪೆಷಲಿ ರೇನಿ ಡೇ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಏನಾದ್ರೂ ಅಲ್ಲಿ ಆಯಿಲ್ ಅಥವಾ ಪೆಟ್ರೋಲ್ ಏನಾದ್ರೂ ರೋಡ್ ಮೇಲೆ ಬಿದ್ದಿದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಅದು ಏನ್ ನಮ್ಗೆ ಶೈನ್ ಆಗಿ ರೇನ್ಬೋ ತರ ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ ಆಯಿಲ್ ಡ್ರಾಪ್ಸ್. ಹೌದಾ? That is all because of what? The interference of light ಆಗತ್ತೆ ಅಲ್ಲಿ. The interference of light phenomena takes place. Yes, option B is right. Then our next question, for constructive interference to take place between two monochromatic light waves of wavelength lambda, the path differences should be the path difference should be, yes, 2n minus 1 lambda by 4, 2n minus 1 lambda by 2, n lambda, 2n plus 1 lambda by 2. So again, theory discuss ಮಾಡ್ಬೇಕಾದ್ರೆ ನಾವು here discuss ಮಾಡಿದ್ವಿ question ಅನ್ನ. Yes, what is the answer? Yes, correct. What about other students? So that is option C, n lambda is right here. Okay, then the next question. So some questions are repeated. So the next question is, soap bubbles appear colored due to the phenomena of. Yes. Dispersion. Dispersion is what? Dispersion ಅಂತಂದ್ರೆ ಏನು? Splitting up of light into the 7 colors when it is passed through the prism. Yes, it is. Option A correct. Yes, option A correct agide. That is interference here. Interference. Then the next question. So here the question is little incomplete. So I'll take the next question here. If two light waves having the same frequency have intensity ratios 4:1 and they interfere, the ratio of maximum and minimum intensity is pattern. Okay, so this one again, you can try this. Other students? Okay, option A is correct here. Then the next question. Option A or C it is. Okay, the next question is evidence for the wave nature of light cannot be obtained from. It cannot be obtained from reflection, Doppler effect, interference, diffraction. Wave nature cannot be obtained from. Wave nature cannot be obtained from Doppler effect. Yes. So Damini, Shilpa, you people are right. That is reflection. Cannot be anta keltidaralli. Can be anta alla. How the option A is correct here. Option A is correct. Next question. Wavelength of light of frequency 100 hertz is. So illi wavelength calculate ಮಾಡಕ್ಕೆ ಕೇಳ್ತಿದ್ದಾರೆ ಅವರು. Yes. So another one question. I'll go for the previous year questions. Another one question I'll discuss here. Here they're asking you to calculate the wavelength of light of frequency. So wavelength is the question mark. Wavelength is given by C by lambda. Sorry, C by frequency. How the C is 3 into 10 raised to 8 divided by the frequency is 100. Yes, option A, B, C, D. Which one? Which one? B. D. Abhishek, you are getting D or B check? Correct. So it is option B. It is option B. Aita. Then one more last question from this slide. As you people are asking for the previous year questions, we will go for previous year questions. Two waves having intensity in the ratio 25:4 produce interference. How the ratio of maximum and minimum intensity is. So again, it is the same question. So itara question se jasti ide. You can simplify this. We will go for the previous year questions. Okay. So here we have 2017 Karnataka CET question. That is, according to Huygens principle, refraction of light. Okay. According to Huygens principle, refraction of light from air to a denser medium. According to Huygens principle, the refraction of light from air to denser medium. Option A, wavelength decreases but speed increases. Option B, wavelength increases but speed decreases. Then option C, wavelength and speed both will increase. And the option D is wavelength and speed will decrease. Yes. What will happen according to Huygens principle? When a light ray is traveling from air to denser medium, and the rarer to denser medium ge hogtirbekadre, what happens? Yes, Parvati, you are right. Harshita, you are right. See, when a light ray is traveling from rarer to denser medium, and the refraction phenomena ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ. So when the refraction is taking place from rarer to denser medium, ಏನ್ change ಆಗುತ್ತೆ? Wavelength decreases but speed increases. Wavelength increases but the speed decreases. Both will increase, both will decrease. That is option D. Both will decrease here. Both will decrease. Correct? Okay. Then the next question. So this was 2017 question. Even I have 2011 and all questions. 2011, 10 other questions to ಹೇಳಲ್ಲ ನಡೆಯುತ್ತಾ ಅಥವಾ recent questions only require? So 2011 is there, 12 is there. Is it okay? Okay, okay, okay. No problem. Yes. So here the 2011 question is, wavefront is the locus of all the points. ನಮ್ಗೆ ಏನಂತ ಗೊತ್ತಿದೆ, wavefront is what? It is the locus of all the points where the particles of the medium, vibrate with. So locus is nothing but that is the wavefront is the locus of all the points anta ಹೇಳ್ತಾರೆ, where the particles vibrate with same dash. So particles vibrate with same dash. Option A is phase, option B is amplitude, option C is frequency, option D is time period. Yes, same phase. So all are saying it is same phase. Correct. So option C, same phase, is 100% right. Next question. So 2011, 2017. We have 2014 question here. The 2014 question is a polarized light. So we have a polarized light. So this polarized light is having the intensity I naught, and it is passed through a polarizer. It is passed through a polarizer. I'll repeat. We have a polarized light of intensity I naught, which will pass through a polarizer with making an angle 60 degree. Okay. What is the intensity? What is the intensity of the emergent polarized light from second polarizer? So first polarizer the light ray is passing. So illi with what angle it is getting polarized here? With the 60 degree. So for the second polarizer, what will be the intensity value? The question is clear. The options are I is equal to I naught. Option B is I is equal to I naught by 6. Option D is I is equal to I naught by 5. And option D is I naught by 4. I hope the question is clear to you. Yes, a polarized light is passing through a polarizer with the angle 60 degree and the intensity is I naught. Second polarizer ಅಲ್ಲಿ ಹೋಗ್ಬೇಕಾದ್ರೆ ಅದರ intensity ಏನಾಗುತ್ತೆ? Intensity value I naught by 6 ಅಂದ್ರೆ first as it is ಉಳಿಯತ್ತಾ ಅಥವಾ by 6 ಆಗತ್ತಾ by 5 ಆಗತ್ತಾ or divided by 4. Yes, it is option D. Yes, Harshita, you are right. It is option D. Damini, Shilpa, yes, very good students. It is option D, I naught by 4. It is I naught by 4. Then the next question. So here I have the next question of the year 2019. So 2015 is there, 2019 is there. So 2019 question is, a transparent medium shows the relation between I and R as shown in the figure. So here the relation between angle of incidence and the angle of reflection is here. This is 30 degree. So this is sine of R and this is sine of I. If the speed of light in vacuum is C, then the Brewster's angle is, Brewster's angle value is, options. Option A is 60 degree, option B is 30 degree, then 90 degree, then 45 degree. The relation between I and R is given by the graph. They are asking you the Brewster's angle. Which one? Option? Yes, 100% right. So it is option A, 60 degree. Option A, 60 degree. Yes, very good, students. So now this is 2019 question. Now 2015 question. The polarizing angle of glass is, the polarizing angle of glass is, it is 57 degree. Polarizing angle is 57 degree. A ray of light which is incident at this angle will have an angle of refraction. So angle of refraction ಕೇಳ್ತಿದ್ದಾರೆ ಇಲ್ಲಿ. The polarizing angle of the glass is 57. So that is nothing but the incident angle here. They are asking you what is the value of angle of refraction. Option A 43 degree, option B 25 degree, option C 38 degree, option D is 33 degree. Yes, correct. Yes, very good, Harshita, Parvati, everyone, right? So that is, it is option D. How the option D is correct here. So one more question we will see. So 2019 is over, 15 is over. Now 2016 question. So again 2019 alli matte 2 question kelidare. Okay, so last one question we will discuss for today's class, that is in Young's double slit experiment, the source of white light, one slit is covered with the red filter. So you know that Young's double slit experiment niಮಗೆ ಗೊತ್ತಿದೆ. So in the Young's double slit experiment we will be having two sources here. In that, one source is covered with the red filter, one source is covered with the red filter and the other one is covered with the blue filter. So this is 2016 question. I hope the question is clear here. The source of light in the Young's double slit experiment, one source is covered with red filter, one with the blue filter. So there shall be, options are alternate red and blue fringes, alternate red and blue fringes, option A. Option B, alternate dark and pink fringes, alternate dark and pink fringes. Option C, alternate dark and yellow fringes, dark and yellow fringes. Option D, no interference. Option D, no interference. Yes. Yes, very good. Lohit, Kumar, no interference. Shilpa, yes, very good, students. So these are the previous year questions from your Karnataka CET. I hope it is clear to you. So in the next class, okay, by evening I'll send you the previous year questions. So I'll send it to sir. Sir will forward you in the group. Okay. Yes. If you require any other help, you can ask. Okay, students, this is regarding the wave optics. Tomorrow we will continue with the next lesson. Thank you. Thank you so much. Have a good day.